All right, so Math 7, this is the quiz that we had on inequalities. Again, you have to remember you're solving inequalities just like you'd solve regular equations. The only difference, the major difference, is that when you divide or multiply by a negative number, and I'm going to write that down, when we divide or multiply by a negative number, the inequality symbol switches direction. Okay, and we went over in class why that happens. We looked at many examples of what happens to an inequality symbol because it becomes false if we don't switch it. So just remember that when we go through here. So I'm trying to take this question, which is x plus 7, and it's less than 14, and I want to solve for x. So the left-hand side is simplified. So now what I want to do is zero out any addition, subtraction first. So I'm going to zero out the plus 7 by subtracting 7 from both sides. I get x by itself, which is great. I didn't divide or multiply by a negative, so the inequality is going to stay the same, and 14 minus 7 is 7. This is my answer. Then I simply wanted you to graph that on the number line. So again, put the middle of the number line to be 7, put a couple numbers to the right of it, a couple numbers to the left of it, all right? And it keeps going, that's fine. And then less than 7 means we're open, because it can't be 7, and numbers that are less than 7 are 6, 5, 4, 3, so we're going that way. All right? Question number 2, it says x plus 8 is greater than or equal to 9. Again, it's just x, so I'm going to zero it out. I'm going to subtract 8 from both sides. That's zeroing out the addition. I get x is greater than or equal to 9 minus 8. That's 1. So put 1 in the middle of the number line and go back a couple of numbers. All right? X is greater than or equal to 1. Now we're allowed to include 1. So now at 1, instead of being open, it's going to be closed. And numbers that are greater than 1 go in this direction. So this is your answer to the question in terms of what x could be, and that's the solution set graphed. All right, then I get 4x is less than 16. So to get x by itself, I have to undo the multiplication. I undo the multiplication by dividing. So the 4's will cancel. X is less than 4. That's my answer to my inequality. So I put 4 in the middle of the number line. A couple numbers to the right and left. It's going to be some type of circle on 4, but since it's strictly less than, it's going to be open because it can't be equal to 4, and numbers less than 4 go back here. Moving on to question number 4 of your 9-question quiz. In question number 4, we have 7x is less than 35. That's what I'm trying to solve. So I look at what's happening to x. On the left-hand side, I'm multiplying by 7. So I do the inverse operation, which is division, because I want that to become 1. X is less than 35 divided by 7 is 5. Since I divided by a positive, the inequality stays the same. So 7, 8, 9, 10. Let's go back. 6, 5, 4. That's sorry. I thought 7 was. It's not 7. It's 5. So I'll keep going back. 3, 2, 1. Let's say 5 now is the number I'm going to put a dot on. If it's solid or closed, depends on the inequality. It's strictly less than, so it's going to be open on 5 because I don't include 5. And then numbers less than 5 go back this way. Number 5, I have negative 63 is less than 7x. Now this is where some of you guys had questions on the quiz. Just keep things simple. I divide by 7. I divide by 7. So x. Now, did I divide by a negative number? No. 63 was already negative, but I'm dividing by a positive 7. So the inequality sign is going to stay pointing in the same direction. And then we do this normally. A negative divided by a positive is a negative, and 63 divided by 7 is 9. So this is x is greater than negative 9. So I put negative 9, then to its left would be negative 8, negative 7. To its right, to its left would be negative 10 and negative 11. X is greater than negative 9. So open circle on negative 9. Numbers greater than, because it's open on the side of the x, so this is x is greater than, looks like this. Number 6, we get negative 3x is greater than or equal to a negative 12. Now, we're going to try to get x by itself. To do that, I need to divide by a negative 3. Do the numbers first. This is what people got confused with. everything is normal when we solve the inequalities, just like they would be with equations. So a -3 divided by a -3, they would just cancel, leaving you with a positive x. A negative over here divided by a negative is going to be a positive. 12 divided by 3 is 4. All right? The only thing now is normally the inequality sign would be brought down. Since I divided by a negative number, this thing has to switch and change directions. That's all. Only because the bottom number here that I'm dividing by is negative. So now this is my answer, and now I have to graph it. So I'm going to make sure I put 4 on my graph, then there's 5 and 6 and 7 and 3 and 2 and 1. Less than or equal to 4. Since it's equal to, I can put a solid circle that's equal to 4, and numbers less than go this way. All right, going on to number 7. Now I have a two-stepper. 7x plus 9 is greater than or equal to 30. You solve this just like it was an equal to sign. I'm going to take care of, now remember, it's always sad map when you have multiple pieces and we're trying to undo. So when we solve, we take care of any addition and subtraction, which means I'm going to subtract 9 from both sides. These will zero out. That's 7x is greater than or equal to 30 minus 9, 21. Next step, undo any multiplication by dividing. X is greater than or equal to 3. That's my answer. I come up to my number line. I put a few points on it. Okay? Greater than or equal to 3, it's solid, and greater than sends me this way. I get 3x minus 5 is less than or equal to 1. Okay? So if I'm less than or equal to 1, solving for this, treat it just like it's an equal sign. I'm going to zero out when I need to zero out on this side. In this case, it's a minus 5, so I'm going to add 5 to both sides to get that to become 0. On the left-hand side, that leaves me with 3x. There's my inequality symbol. It stays the same because I didn't divide or multiply by a negative. 1 plus 5, 6. I'm going to divide by 3, divide by 3. I get x is less than or equal to 2. So there's my 2, my 3, my 4, my 5, my 1, my 0, my -1. This is my answer. Less than or equal to 2 means I can include 2, and numbers less than it go this way. And then last question, number 9. 6x plus 8 is greater than or equal to 26. Once again, SADMAP tells me I got to undo any addition and subtraction, so I'm going to undo the addition by subtracting 8. Again, we subtract it because it's the inverse, and the other way of thinking about it is we want to zero it out. So I got 6x greater than or equal to 26 minus 8 is 18. Here I want to do the inverse of multiplying, so I'm going to divide, and you divide by what you're multiplying x by, which is 6. This way they cancel, leaving me with x because that's what we want to get by itself, is greater than or equal to. I divided by a positive, so the signs are going to all stay the same. 18 divided by 6 is 3. That's my solution. And then graphing that solution, couple numbers in front, couple numbers behind, greater than or equal to, it's solid, and greater than goes that way. Okay, so that is the quiz on the inequalities that you guys just took. Hopefully we did well.